Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little's Law YouTube channel. So, in our last few videos, we were discussing about the performance engineering concepts, where most of the times we used to see an increase in performance. It's because mainly because of the databases. So, in this video, we will see about how to tune our query so that we can increase or improve the performance. And in fact, there were like many other options to improve the performance, something like uh, reducing the space in the the amount of size of data that's been sent using the front end, like something like the JS files that we use, or the amount of other supporting files that we send. But again, yeah, like there were like a lot of things to discuss, but for now we will see how to improve the performance using uh, the database. Like in this video we'll see about how to write a stored procedure and what is the difference between a stored procedure and query, and we'll see how to use that to improve the performance. So firstly, I have a query here, and before we move on to this video, this is me, Vasan Shanmugam. I welcome you all to our Little Sly YouTube channel. Please don't forget to subscribe to our channel, give a thumbs up, a like, share your questions and feedback in the comment section, and don't forget to join our WhatsApp channel. And please do consider joining my channel so I can create more quality content like this. And yep, with no further delay, let's go to the video. And now, uh, yeah, so the main difference between a standalone query, something like this, and a stored procedure is, so the main difference is the performance optimizations, because a standalone query, so each time when it is executed it needs to be parsed, compiled and optimized by the MySQL server or whatever server we use. It can be a Microsoft SQL server, or it can be a NoSQL or MongoDB or whatever DB database. So the query, each time a standalone query, it needs to be parsed, compiled and optimized. So just imagine how much time does it take every time when you are sending query, and when every time, like when multiple users are sending a query. And if the query is complex and executed frequently, this overhead can be significant, which is it will take a lot of time, and it will in turn increase the amount of CPU utilization in the database server. So it in fact, in turn, it will increase the response times. It will slow down the machine. You can experience timeout. You can experience no response to uh, the final the to the presentation layer. So to avoid all these, we can move to stored procedure, because the stored procedure is parsed, it's compiled and it's optimized once when it is created. So the moment when you create it, it all these parsing, compilation, optimization has been done, right? And subsequent executions of the stored procedure can be faster because the execution plan is already cached. So you don't need to worry about the subsequent execution. Right? And then the second point is the reusability. When it comes to standalone queries like this, so we need to write and send the query to the database server each time when we want to execute it. So when we are running a test, every time the query has to be sent to the database server. And if in case if we need to change the logic, we must update the query in every place it is used in our application. Like for example, if we are using this query in several places, then we have to everywhere go and change this. But on the other hand, when it comes to the stored procedure, the stored procedure encapsulates the query logic in a reusable form, and that's the main advantage of using the stored procedure. And we can call the stored procedure from different parts of our application without rewriting the query. So we do not need to write everywhere. We can just call the stored procedure and that will do whatever it needs to be done. And to change the logic, we only need to update the stored procedure once, and all calls to it will use the updated logic, and that is about the reusability. And coming to the maintainability, that is another hectic task which every database team, or in fact as a performance engineer, we also will face, because any changes in the business logic will require changes in multiple places in the application code wherever the query is used. And this finding it and replacing it and rewriting it will lead to inconsistencies, because you might be missing in some places and you might be rewriting in some other places, and it leads to a lot of errors. And if not all instances of the query are updated correctly, if nothing if not everything is updated correctly, then we might be facing some issues or errors, right? So that's the reason of maintainability. But there is an advantage when it is coming to store procedure, because you encapsulate the business logic all in one place using the store procedure, and it makes the code base very cleaner and easier to maintain since the query logic is centralized. And coming to the security, because in fact this again this is not part of the performance, but again this is again part of the non-functional requirement, where the applications often concatenate user inputs directly into the SQL queries, which can lead to SQL injection vulnerabilities. And proper parameterization or escaping of units is required to prevent such attacks. But when it comes to the store procedures, the parameters are passed to the store procedures, which reduces the risk of SQL injection. So in case if in terms if you are approaching the databases, the queries from a security perspective, you can advise this point, right? So you do not need to worry about passing or like about the SQL injection, and the database server can enforce security policies on store procedures, such as we can restrict the permissions to execute certain store procedures. Finally, the network traffic, that is sorry, that's another highlighting point, because whenever when we run a standalone query, so every query execution involves sending the entire query string over the network. And just imagine if you have a very big query, and just imagine you're sending the entire query string over the network, which adds more what to say, you're occupying more data in the network traffic, and especially for large and complex queries. That's again, if you see the network input output or network latency, you can see that your database queries occupies a lot of its bandwidth, which in fact will increase the performance time, right? In all cases, we were trying to give stress to the application whenever you're running it through a query. But when you're running it through the store procedure, only the call to the store procedure and its parameters are sent over the network. And this, it'll be like one line of data, one line of query when it comes to the store procedure. And this can reduce the network traffic, and particularly when the procedure contains complex logics or multiple SQL statements. Right? So that's the reason it's always advisable to keep all the queries. I mean, like to keep all these queries, you can migrate it to the store procedures whenever it's possible. Yeah, so now we will see how to convert this query into a store procedure, and it'll be a more interesting process. So please do follow me. And yeah, so here I have a query which tells us about selecting the first name, the last name, the film title, the category name from tables like actor. And yeah, so this is the table which I'm using. So I'm going to use the film actor, the table actor, sorry. And then I'm joining the tables. The actor and film actor are joined to link actors to films, and then the film actor and film tables are joined to get details of the films, and then the film and film category are joined to get the categories of the films, and finally the film category and the category are joined to get the name of the categories. And then I have a subquery, but again, this is another way which I have mentioned previously. Avoid subqueries. Do not have subqueries in your queries. That will add more time, uh, uh, more pain to your query, or like in fact it will increase the response time. That's the whole objective. So it will increase the response time. It will occupy a lot of CPU utilization, right? So the subquery here, select name from category where category ID equal to 1, retrieves the name of the category with category ID equal to 1. So if anybody who has their category with category ID 1 will be selected, and this ensures that we are filtering films that belong to this specific category. And yeah, to know more about that table, just go right click on it and do a select rows limit 1000, and this will show us that if the category ID, so the category ID, if it is 1, then the name of it is action. So if it is category ID is equal to 1, then we are going to pick the action movies. So that's the reason we are using this category ID equal to 1, and that has been used as a uh, subquery. So we are now going to replace this into a store procedure, and then I will show you how to call this using a store procedure. So now to show you like how to create a query to a store procedure, I will show you in this way so that you can compare and understand how does this work. I mean, converting a standalone query to a store procedure. So first, a store procedure starts with a delimiter. So let me start with the delimiter, and this is again with the MySQL. So it's delimiter slash, I mean forward slashes, and then I'm going to create a procedure. So this is the procedure to start a procedure, to start a store procedure. And just a moment. Yep. So then I'm going to give a name for the store procedure, which is going to be get actors by category. and then I'm going to pass a value. So this value which I'm using now is the value that we can use to pass the arguments. So I'm going to use as p underscore category underscore id, and then it's going to be a small int, so a variable type of it. So it's going to be a small int, and I will tell you like how why do I keep it this way. And I'm going to start. So to begin your store procedure, you have to add begin, and then I'm indenting it, so which is going to be select, and then again it's going to be the same thing. So what I'm going to do is, instead of writing it, I'll just copy paste it so that you can easily understand. So what I'm going to do is I'm going to select the actor dot first name, because these are the values which we want to retrieve, right? So the actor dot first name, the actor dot last name, the film dot title as film title, category dot name as category name, from actor join film actor on actor id. So I'm going to choose until the last join. So I have chosen until this point, and I'll copy it here, and then I'll paste it. So now I have got the query part here. So in this, I'm joining these tables, which is the film actor, actor ID, and then the film ID, and then the category. And then I even have joined the category ID with the category ID of the other table, the category table. And now the important point here is like here, I'm going to rewrite this subquery here. So I'm going to write it as where category. So the same way, so if you see here, I've got the category here, the category table dot category ID. So I'll just copy this from here. So what I'm doing is I'm just uh, rewriting this in another way. That is, I'm going to rewrite this subquery into a where condition. So which is, I'm taking this table name and then this column name equals the argument that I have passed here. That's it. So simple. So what did we do so far is we have started. Okay, let me just complete it for now. Okay, and then let me add a colon, and then we'll add a end to the store procedure, and then I'll add a delimiter with a semicolon. That's it. So what did I do? What did I do so far is like I created a store procedure with a delimiter start and then delimiter end, and then I'm creating a procedure with a procedure name. So this is the name of the procedure, and then I'm passing the values. In fact, I'll show you with multiple parameters in our next video. So for now, I'm passing it with only one argument, that's a p category id, and which is a small int, and then I'm copying the same query that we have used in the store standalone query, but I've started it with a begin, and then I have ended it with end, with the forward slashes, and then inside it I have copy pasted all this, but then I have rewrote this subquery in a way that the category dot category id is equal to this parameter. So if I pass the value 1 in my store procedure, this will pick the values which I wanted to pick. And then yeah, so far what I did is I just replaced a standalone query into a store procedure. So now we will run this query and see how does the store procedure work. So let me copy this, and then I'll go back to the MySQL, and then we'll paste this and run it. So before that, let me see. So far I do not have this get actors by category store procedure under the store procedure link. So if you see here on the left side, I do not have it. So when I run it and refresh, yep. So now I have got the get actors by category. So it has been created successfully. And if you see here, yep, so it has worked, it was successful. And now to test this, that is to test my category, my store procedure. So I'll open another window, and here if I'm running this, so what did I do is I have created a store procedure get actors by category, and I'm just using it. So I'm just calling it call get actors by category. And previously, if you see in my query, I have used the category id value number is equal to 1. So I'm using the same value which I'm passing it as part of the p category id. So just I'm using 1, and if I run it, let's see the results. Yep, so it's very quick. I have got it in. If you see at the bottom, it's like 0.015 second. It's like too quick. On the other hand, if I'm running this query, let's see how much time does it take. Yep. So previously I think it is cache. So for now it's returning this. It's a very quick. So yep. So for now, yep. So I have converted this value into a. So yeah, in fact, we will try this other one. Like for example, if I'm running, if I want to try a different category ID, let's see how much time does it take, right? So previously it is executed, it has returned 363 queries, and now when I'm running this, it has returned 361 queries. Yep. So same way, if I want to make any changes in the category ID, like for example, if I want to get a different set of values, just select this, and if I select two, this will pick up another set of categories. So for example, animation here, right? So that's how the store procedure works. So you do not need to change the entire code, like, or you do not want to go inside the code and make the changes. Like you can just change that, make the changes only in the store procedure, and it will do whatever we need to do. Yep. So yeah, I think this one I will give you some idea, because nowadays nobody wants a performance tester, everybody wants a performance engineer. So in case if you are confident in doing this, you can give this as an example in your interview as well, right? And you can be very confident. You can tell them that, see, this is how you can convert a query, that you can tell that I have converted a query from this one to this store procedure, and this is an example, and this has improved the performance. And yeah, in fact, in our next video we'll see how to do with this with the multiple parameters, and that will in fact will increase a lot of knowledge in terms of your store procedure and in terms of your performance engineering. So with that, yep, I'm coming to the end of this video, and we'll meet in another video in our next video. Until then, it's bye bye from Vasanth and Mo, and if you're at Little Star YouTube channel, bye bye. Take care, and all the very best for your interviews.